The Kalani is a beautiful 145 kilometers long river in Sri Lanka, supplying Colombo City with 80% of its drinking water. Communities benefit from the river for water use, recreation, and culture. During 2016, Sri Lanka was hit with record rainfall and the resulting floods were the worst in 25 years. The World Bank Climate Resilience Multi-Phased Approach Project aims to modernize disaster forecasting, preparedness and warning, and improve flood resilience in the Kalani River Basin. One of the major activities of the project is the reconstruction of the Ambathale Salinity Barrier on the Kalani River. The Ambathale Salinity Barrier, a weir, located 16 kilometers from the sea along the Kalani, prevents saline water intrusion into the intake of the Ambathale drinking water treatment plant. The project will finance the reconstruction of the existing static weir with a new mechanically operated weir that allows for more efficient operation of the gates. With flood resilience top of mind, 3 engineers from the Sri Lankan Ministry of Irrigation came to Japan in June 2023 to learn how large hydraulic structures aimed at resilience are designed, tested, and built. Complex hydraulic structures need high performance and reliability, and many such structures have been built and safely operated in Japan for years.
So this is a good opportunity for to share Japanese experience. So during the site visit, we see how hydraulic structures in Japan is designed and tested in using the numerical modeling and then also the physical modeling with a combination.
The training was divided into 2 parts. The lectures and discussions were held in Tokyo, and the modeling experiment was performed in Tsukuba at a large experimental facility owned by the training provider. The training began with participants engaging in lectures and discussions about theory, specifically fixed bed and movable bed experiments.
And if you see something to your naked eye, so it makes a very big difference and makes sense. So I'd like to thank for us to giving opportunity to see these things in Japan, in your country.
An experimental method called physical modeling is often used in Japan when designing critical water infrastructure. Participants were able to work with Japanese counterparts to conduct such experiments. A long 4 feet wide rectangular channel was used during these experiments, allowing for many potential scenarios to be tested. First, participants tested a static weir, representing the existing salinity barrier, to better understand the sediment accumulation pattern near the weir. And then they built and tested the proposed new gate structure in the experimental channel. The structure was built with a manual gate operation function based on the latest design of the new salinity barrier. In addition to testing different flow rates and water levels, they tested different gate operation conditions to gain insight around sediment scouring and deposition near the new gates.
Yes, especially when we come here, we didn't have enough experience in moving bed model studies. That kind of study exposed us to with much more knowledge as well as practical experience.
The visiting engineers also made 2 site visits to enhance their comprehension of Japan's urban flood protections. They first visited the Tsurumi River multipurpose sports field, which can store more than 3.9 billion cubic meters of water from the Tsurumi River, protecting Yokohama City, which is located downstream. They also visited the metropolitan area outer underground discharge channel and pump stations, a major component of the urban flood protection infrastructure built in Tokyo. With the 2-week training program, the trainees from Sri Lanka gained basic knowledge and hands-on experience on physical hydraulic modeling, acknowledging the importance of hydraulic experiment to review and refine complex hydraulic structure designs. Together, we continue to support resilient infrastructure in South Asia.